Hi students, good morning. Welcome to this video session. My name is Samuel Dominic Chukwu Emeka, aka Sam Dom for Peace. In this video session, we are going to look at a special limit. We are going to discuss limit of the function sine theta divided by theta as theta approaches 0. Okay. If I speak like an American, it will be as theta approaches 0. If I say it like Nigerian, it will be as theta tends to 0. Okay, whichever one. Theta approaches 0, theta tends to 0. So this is, I call it a special limit because we are going to use this to determine the derivative of sine theta and cos theta. That is going to be in under differential calculus. So we are going to use the knowledge from this video to determine the derivative of sine theta and cos theta. So that is why I call it a special limit. The notes, the transcript of this video can be found on this website, www.limits-continuity.axpot.com. Okay, so it is recommended, highly recommended, that you have an understanding of limits. If you go to this website, you click on videos and you see a playlist. It is recommended that you start from the first video, okay, in that playlist. So we are going to do this in two ways. We're going to do it in two ways because if you just use your calculator and do sine 0 divided by 0, of course you cannot divide anything by 0. That would be indeterminate. Okay, if you do it in your calculator, it gives you an error. So but this has a value. This is determinate. It has an answer. So we are going to do it two ways. We're going to do it numerically and algebraically. Algebraically, I will also say by geometry. Okay, we're going to use the manual method. I call it the manual method, which is numerically. And then we use some geometry and algebra to do it algebraically to find the limit. Okay, so let us start with numerically. So it's my assumption that you have an idea of the manual way. I call it manual method, which is numerically, finding the limit of a function numerically. And of course, finding it numerically is a very is a highly recommended way of finding the limit of a function. So this theta is in radians, so that is note. Theta is in radians. RAD, radians, is in radians. Radian measure. Okay, radian measure of angles. Trigonometry. So we are going to have it this way. We will have theta. We are doing it the first way. We're going to do it numerically. First method, numerically. First method. First method. So let's have it this way, because it's we're doing numerically. I recommend, okay, we are going to find the left hand limit and the right hand limit as the angle theta approaches 0. So, and I recommend at least five values. Okay, if you view the video I did on numerically, I normally recommend at least 5 values from the left hand and from the right hand. So we are going to find the left hand limit and the right hand limit. We're going to find limit as theta approaches 0 from the left, and then limit as theta approaches 0 from the right. So I'm going to write theta here, theta, and then I will write sine theta. Then I will write, so I'm going to write theta. Let me just draw the line. Okay. Then I'll write sine theta. I draw the line. Then I will write, let me make this double line. So just to where we can find our answers, okay? Let me use double line to demarcate it from our answer. So the next one will now be sine theta all over theta. Alright, so we're gonna do, I normally recommend 5 values. So let's have it from negative 0.1 and then 1. Let's have this middle here. Let's kind of have this middle here where we can have a 0. Where we can now have a 0. Okay. So I will have here from negative 0.1 let's negative 0, let's see if we can make it like to increase the width. Negative 0.1. Then I have negative 0.01, negative 0.001, negative 0.0001, and finally negative 0.0001. Okay, 1, 2, 3, 4, 5 from the left hand limit. Okay, the same way here I have here 0. I can just go ahead now and do this 0.0001. Then I have 0. This is 0.00001. Okay, this is 0.0001. Then I have 0.0001 where it's approaching it. This is approaching it from the left. Okay, this is actually, if I just write it where it should be, this is approaching it from the left hand limit. Let me use yellow chalk to write it. Limit as theta approaches 0 from the left. That is this here. And this will be the limit as theta approaches 0 from the right, this area. So it's approaching it from, everybody is going towards 0. That's why it increases up to 0. Because limit is, gradual increment. A gradual increment towards that value. So this is approaching it from the left. And this here is approaching it from the right without actually being 0. It's just approaching it from the right. And here it's approaching it from the left. Okay? This will be 0.001, and then 0.1. Okay? 1, 2, 3, 4, 5. Yeah. Anyway, you have, I know this doesn't look uniform, but at least the spaces, but at least you have, the idea. It's good to make 1, 2, 3, 4, 5. It's good to make it 5 values at least. It's recommended, 5 values. All right. So I have my simple calculator here. Simple one, Casio. I don't know, but this is many years I've been using this. Okay. Oh, Casio will not pay me anyway. I know I mentioned Casio. Will Casio pay me? They are supposed to give me some money, right? But I am advertising for them. But I have used this calculator, honestly. I have used this calculator for more than 12 years. Yeah. I know everybody wants TI, right? That's fine. Okay, but if you can use your TI, that's fine. Hey, now, this is in radians, okay? So, just take note of that. It's in radians. We're going to give these values in radians. And we're going to try to round it to at least probably, let me see anyway, to see, round it to a sizable number of decimal places. So first of all, you make sure that your angle is in radians. First of all, make sure it's in radians. And if you want to know how to convert this to radians, you can go to my website, trigonometry.appspot.com, and you look at angles and the angular measures, and just follow the instruction. This is Casio FX9750G plus. That's this. Like I said, I have used it for more than 12 years. So I will first of all go to Shift Setup and go to Angle. It's in degree, DEG. I convert it to radians by pressing F2. Make sure it's in radians. And then I press Execute. Okay. Then you might want to try to make sure assign 180. 180 is I radians. Okay, to just make sure that it gives you the correct thing. Now it's in radians. Some calculators you have DRG, degree, radian, gradient. Okay, you press mode, check the degree, press it again, it gives you arrow, DRG. Some calculators have it like this, DRG. Degree, radian, gradient. So you make sure it's in radian. This is radian. I'm gonna do sine negative 0.1. Now the negative in your calculator is the one like this. The one that is like this. Some calculators have it like this, plus minus. Plus minus. So don't use the minus sign. I know this is minus 0.1, I know, but don't use the minus sign. use the one that looks like this or like this. Okay? And it's good to put parentheses. So sine parentheses negative 0.1 equal to this is radian. So I have here, you can verify, negative 0.099833. Negative 0.099833 41665. That's what it gave me. So I will go ahead and divide it by, I'm going to go ahead and divide. Divided by negative 0.1. And this gives me 0.99833. I mean, that's what this gives me. Okay? And then I do this sine negative, I put parentheses, okay, sine parentheses, negative 0.01. This gives me, okay, negative 0. Now this gives me this. This is what it gave me, negative 9.99833 E negative 0.3. Okay, so this is probably what it maybe gives you. Okay, now if it gives you this, not a problem. This means times 10 to negative. This means negative 9.9998333 1 2 3 3 1 2 3 4 4 times 10 to the negative 3. That is what this means. The exponential times 10, exponential whereby the base is base 10. Okay, 10 to exponent negative 3, which is 0.001. That's what it means, 0.001. So this is actually negative 0.00999833334. That's what it means. This is what it means. Okay, negative 0.00. That is what this, if you this in a scientific notation, and now this is in standard notation. So negative 0.009998333, and I go ahead and divide by negative 0.01, and it gives me 0.999833. See, this is 0.998. This is 4. 0.9999, 4 nines, 8. So this is 2 nines, this is 4 nines. Kind of gives you an idea where it's going, you know, as it approaches 0 from the left. Where it's going gives you the idea. Okay, we do the next one. Sine negative 0.001, and this gives me negative 9.9999833 E negative 0.4. So times 10 to negative 4. That is what it means. So this is negative 4 zeros, 0.000. Okay, 99983. Then divide by negative 0.001. So this gives me 0.999123456 6 nines. 1 2 3 4 5 6 8 3. So this is 2 nines, this is 4 nines, this is 6 nines. So already you can see the sequence that this would probably be 8 nines, or Or let's just see what it will give us. Okay? But at least you see the sequence here. 0.99, 0.9999, 9999. This 0.99999983. Okay, we do the next one. Sine negative 0.0001. And that gives us 5 zeros now. So this is negative 0.12345. Okay, 99 99. Actually, this 99. Actually, this one is 9999. This one is actually 999. Okay, this one is actually 999 for this one. At 9, it's actually 1, 2, 3, 4, 5, 6. Yeah, 6 nines actually. Okay, this one I corrected it. 6 nines, but I just stopped it as, you know, I stopped it as. Let me finish. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 8. Okay? Yeah, this is okay now. And this one is 1, 2, 3, 4, 5, 6, 7, 8. 8 nines. 8 nines. Okay? 9999. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You know, that's okay. You understand what I'm doing. Okay? Then divided by, you can have more space in your paper to finish it. Okay? Then the last can be 83. Then divided by negative 0.0001. Okay? So this gives us here 0.12345678. Yeah. 1, 2, 3, 4, 5, 6, 7, 8. 83. 1, 2, 3, 4, 5, 6, 7, 8. Alright. So it's giving us, you know what it will give. It's approaching to 1. You know, it approaches 1. We do the last one. Sine negative 0.00001. Okay, this gives us negative 1 times 10 to the power 5 times 10 to negative 5. So this is negative 1, 2, 3, 4, 5, 1. This is what it gives me. Okay, divided by this is 1 right away. So this gives me 1 from the left. Okay, now let's also see what it gives us from the right. So here we do, if we start from the right here, sine 0.1, this gives me 0.099833. Okay, just, you know, the same as this, just the difference in signs, divided by 0.1, but you know, it's good to still verify. 0.99833. Okay. And we can just draw this here. We can just draw this, that this is giving us 1. So at least you have an idea of this. Okay, you have an idea of this at least. Sine 0.01, 0.0099983 divided by 0.01, 0.999983. 4 nines, 2 nines, 4 nines, sine 0.001, so 0.000 1, 2, 3, 4. So 6 nines. 1, 2, 3, 4, 5, 6, 8. Divided by 0.00. Okay. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 4, 5, 6. All right. And this is the same, just the same thing here. 0.0000. Okay. 9, 9, 9, 9. 8 nines. And divided by that. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then this one, of course, 0, 0, 0, 0. So as you can see, this approaches 1. So the answer to this is 1. Equal to 1. Equal to 1. Numerically. So numerically is a sure way. It's a very recommended way to do it. Alright, let's do it algebraically. Okay, before we call it a day. Let's do it algebraically. Second method. But you know, numerically is recommended. You know, is recommended, and it's also straightforward. It's straightforward. It's an easier way to do it. It's just time consuming. You know, it's just time consuming, but it is straightforward and it's easier. It's easier but just time consuming. That's the thing about evaluating limits numerically. Alright, the second method we are going to do with this same thing, second method. Is algebraically and you know, I can also say a little bit of with geometry, algebra and geometry. Okay, so to do this here, we are going to have some idea of geometry. We will consider a circle, consider a circle, consider a circle, and I'm gonna draw this circle here. Whoa, I drew it just one time, thank God. At least it's not bad, right? It's not bad, right? Okay, consider a circle with center. Center, we have this circle. Okay, I'm gonna put this here. We have a tangent to circle. Tangent to the circle. A tangent to the circle just touches the circumference at one point. We have the tangent to circle, and we have this now forming a triangle. Okay? So center, I'm going to call this, I will use yellow chalk to label this. Okay, so we have this triangle. Let me call this A, B, C. Then I have another circle, okay, and I kind of have it this way because I want to have a sector. I want to have a sector. I want to have a sector as well. So here's the thing, folks. Here's what I want to do. I want to see, of course, an angle is formed here, two lines meet, so the angle theta is formed. And let me call this ABCD, let me call this D, let me call this E, I call this E. Okay, this is what I want to do. This is what I want to do. I want to see if I could get sine theta over theta, you know, and why am I using circle? Because if I use only triangle, it's not going to be enough information for me if I use only triangle. So that's why I'm using both triangle in a circle and having a tangent to the circle at C. C is the point of contact. That's the point of tangency. Okay. You know, I want to see how I can get the value sine theta over theta. Okay, that's what I want to see. I'm going to call this algebraic and I'm going to put slash geometry. Okay, because we're going to do some geometry here. So consider a circle, center A. Center A is the center of the circle. I have two triangles. Of course, you know that this is 90 degrees. To the tangency, you know that this is 90 degrees. And you also know that this is 90 degrees. Yeah. Now I have triangles. I have the circle. I have center A. Then I have two triangles. I have triangles. The triangles are triangle ABC, and I also have triangle, like the triangles I'm going to use, okay? I'm not gonna, you know, we have more than two triangles here, but these are the triangles I will use to find the limit of this, okay? Triangle ABC, ABC. Then I have a sector, area of sector, ADC, ADC is a sector, area of sector. Okay, as you can see here, sector ADC. ABC, area of sector, ABC. Okay, because you have it like, you have this sector, it's like this, sector, ABC. Have it this way. You have this sector here, ABC. ABC, sector ABC. And then you have the point of contact. A tangent BC is tangent to the circle. Line segment BC is tangent to the circle. Okay, and the point of contact, or the point of tangency is C. The point of tangency or the point of contact is C. So that's what we need here. Okay, so this is what we're going to do. We're going to find the area of the circle ADC. Then we'll find the area of the sector, area of circle ADC. Then we find the area of sector ADC. Then we find the area of triangle ADC, area of sector ADC, and then the area of triangle ABC. Okay, we will have some inequality, and then we can prove this. Now, this is radius, okay, because this is from the circle center. So this is radius here, and this is also radius. From here to here is radius. Okay, because the radius is the line from the center to the circumference. The point of the circumference is D and C. D and C are points on the circumference of the circle. Okay, points on the circumference. Points on the circumference. Are C and D. Okay, and then radius center A, radius R. Radius R. Okay, now let's do area of triangle ABC. Of course, area of triangle is half base times height. Area of triangle is half base times height. Now the base half times base times height. Okay, now the base here, let me kind of draw this. The base here is R, triangle ABC. So the base is the radius here. Okay. Remember, our theta is still in radians. And then the height is DE. The height is DE. Line segment DE is the height. All right. But sine theta is opposite. We want to find the height, okay? So sine theta is opposite over hypotenuse. So this is triangle ADC. So sine theta is opposite DE over hypotenuse, which is R. And this is SOHCAHTOA rule. SOHCAHTOA. Please, if you are confused what I'm doing, you go to trigonometry.appspot.com. Trigonometry. www.trigonometry.appspot.com. That is if you don't I mean before you do calculus, you must pass trig very well. Okay. This is calculus. Before you take calculus, it's required that you take pre-calculus, and normally pre-calculus is taught with trigonometry. Some schools call it pre-calc with trig. No, not just pre-calculus, but pre-calculus with trigonometry. Alright, so this is what I'm doing. So DE is arrow sine theta. Okay, DE is arrow sine theta. Alright, so now the area of triangle ABC is half times r sine theta, and that gives us half r squared sine theta. So we keep this half r squared sine theta. We keep it. Okay? Now the next thing we'll do is area of sector. Okay, because in terms of area, we'll see that the area of this triangle ABC, okay, if I shade it, is less than the area of sector, and the area of sector is less than the area of the triangle ABC. Okay, area of triangle ABC, okay, if I shade this here, this is area of triangle ABC here. I have only yellow chalk and white chalk. So now this area here, area of triangle ABC, is less than the area of this sector. The sector is if you include this. Okay, you have the area of the triangle plus this here, plus the area of this segment. That gives you the area of the sector. Okay. The area of the triangle ADC is less than the area of the sector ADC, and then it's less than the area of triangle ABC. And then from there we can do something here. Okay, that's the thing. So that's the area here, area of triangle ABC. Now let's find area of sector. Area of sector ABC. So which is the area of this triangle ABC plus this area here, we say segment. Okay, that's the minor segment. Area of segment DC gives us the area of sector ABC. See, that's the sector here. Because this is the triangle, plus this here gives you the sector. Okay, area of sector. Now, area of sector is theta over 360 times pi r squared. So because it's the theta over 360 times the area of the circle. Okay, that's the minor sector. That's area of the minor sector. Is the minor sector. So 360 is 2 pi r, no? 360 is 2 pi r. So this is theta over 2 pi r times pi r squared. Okay, so this crosses out. Pi crosses pi, 1 arrow crosses 1 arrow. Okay, so area of sector ABC is 1/2 theta r. 1/2 theta times r. That's the area of the sector. So we keep that. Okay. 1/2 theta r. Right? Theta over 360, 2 pi. Oh, sorry. 360 is 2 pi, not 2 pi r. Don't mind me. Sure. 360 is just 2 pi. I'm sorry, not 2 pi r. Sorry. I am a human being. I make mistake. But thank God that I fixed it. Right? 360 is just 2 pi. So this is theta over 2 pi times pi r squared. So this is 1/2 theta r squared. Okay, 1/2 theta r squared. Okay? Yeah, 1/2 theta r squared. Alright, the next one is, now the area of triangle ABC is less than the area of sector ADC, and that is also less than the area of this triangle ABC. So that's the next thing we'll do. Area of triangle ABC. Area of triangle ABC. Okay? Of course, it's half base, half times base times height. So the base, of course, is the R as well. Base is AC, which is R. The base here is also AC. AC, line segment AC, which is your R. That's the same base. Now the height is BC. The height is line segment BC. That's the height. This is considering triangle ABC. Okay, this is considering triangle ABC. This is considering triangle ABC. So the height is BC. So what connects the height? Let's find the trig ratio for the height. So this is opposite over adjacent. So tan, which is tan theta is opposite, which is BC, over adjacent, which is R. And this is SOHCAHTOA rule. So BC is R tan theta. BC is R tan theta. So this implies that area of triangle ABC is equal to 1/2 times R times R tan theta. Okay, which is 1/2 R squared tan theta. Okay, folks, we have this here, and we have this here. All right. Now let's do some algebra. We now have to do some algebra. We will now have to do some algebra so we can get this done. So can I just erase this part here? So we can go ahead and finish this. So we now have that this area of triangle ABC have 1/2 R squared sine theta. In terms of area, let me put this in terms of area. Okay. Area of triangle ABC is less than area of sector ABC, and that is less than area of triangle ABC in terms of area. Okay. This area is less than area of the sector and is less than the area of the triangle. This you can see. Okay. So now we say that 1/2 R squared sine theta is less than 1/2 theta R squared, and that is less than 1/2 R squared tan theta. Okay? Divide everybody by 1/2 R squared. Divide all terms by 1/2 R squared. Okay, because it crosses out. So this is 1/2 R squared sine theta divided by 1/2 R squared is less than 1/2 theta r squared divided by 1/2 r squared less than 1/2 r squared and theta divided by 1/2 r squared. Okay. So what we got? So please let me erase this so we can finish up. So we now have that sine theta is less than theta is less than tan theta. Okay? Sine theta is less than theta less than half theta. Remember, we want to find this sine theta over theta. So let's now do something. This means that, of course, tan theta is sine theta over cos theta, and this is quotient identity. Okay, quotient identity. Quotient identity. Okay, so this means that this is sine theta is less than theta less than sine theta over cos theta. Alright, then multiply everybody by 1 over sine theta. Multiply. Now we want to put this sine theta over theta in the middle. That's what we want to do. We want to see the bound. We want to see if it's in between some bounds. Okay, so that's our goal. Okay, so now divide everybody by sine theta. Divide everyone by sine theta, or just multiply everybody by 1 over sine theta. Okay, if you want to do that, multiply by 1 over sine theta. Multiply all terms by 1 over sine theta, or you can say divide all terms by sine theta. So this will be sine theta times 1 over sine theta is less than theta times 1 over sine theta is less than sine theta over cos theta times 1 over sine theta. Alright? So let me go ahead and erase this here. So this, I now cancel this. So I have that 1 is less than theta over sine theta, and that is less than 1 over cos theta. Okay, I'm coming there, you see. We are coming there. Because remember, we want to do sine theta over theta. That is our goal. That is our goal, to find that. So why don't we just flip everybody. Okay, flip everybody. Take the reciprocal of all terms. Take the reciprocal of all terms. Take the reciprocal of all terms. Now, when you're taking reciprocal, okay, so let me explain something here, folks. If we have something like this, you know that 2 is less than 3 is less than 4, right? 2 is less than 3, 3 is less than 4. If we take the reciprocal of all the terms, so 1 over 2, 1 over 3, 1 over 4. Should we still put less than? See, that's the thing about inequality. if you're taking reciprocal, okay, if you take reciprocal, the inequality flips. It's reversed. Okay, because 1/2 is 0.5. 1/3 is 0.333333. 1/4 is 0.25. So this will now be greater than, instead of less than, it will be greater than. Okay. So this is 1/1 will now be greater than sine theta over theta, and this is greater than cos theta over 1. So we now have that 1 is greater than sine theta over theta and greater than cos theta. Now we find the limit, okay, the limit of each term. Of course, limit as theta approaches, this algebraically now, as theta approaches 0 of 1 will give us 1. Okay? Limit as theta approaches 0, as theta approaches 0 of cos theta. So this will give us cos 0, and cos 0 is 1. Cos 0 is 1. Okay? If you do it in your calculator, cos 0 is 1. Now sine 0 is 0, but cos 0 is 1. So now, you now see that we have 1 greater than sine theta over theta from the limit. If we now take the limit, okay, limit as theta approaches 0. So this will now give us 1 greater than sine theta over theta greater than 1. So sine theta over theta, the bounds are within 1. You see that? So because of that, we now say that limit theta approaches 0, sine theta over theta is equal to 1. This is very important concept because we are going to use this concept to determine the derivative of sine x and cos x. That concept is very important. Okay, folks, thank you so much. That will be in differentialcalculus.appspot.com. Differential-calculus.appspot.com. Derivatives of basic trigonometric functions. Okay? Alright, folks. I hope you understood it, right? If you have any questions, please feel free to ask. Thank you for listening, and you have a great day.